Two more examples from 7.3. So number 7, it says x cubed plus 216 equals 0. And I give you a hint. I want you to factor with the sum of cubes first. Okay, so if you remember, we're doing the quadratic substitution. So we're going to see what happens first. All right, so sum of two cubes. If you remember sum of two cubes formula, if you had a cubed plus b cubed, when you factor it, you have a little binomial and then a big trinomial. Do you guys remember what goes in those spots? A plus b. Close. The signs are wrong though. How do the signs go? Same, different, plus. So same as what it was. So plus, different, plus. Okay, so same, different, plus. Oops. All right, so a cubed plus b cubed equals a plus b times a squared minus ab plus b squared. Okay, so in this case, 216, any guesses as to what multiplied by itself 3 times makes 216? 4? Nope, that's 64. 8's too big, I think.
Oh, we like 6.
Yeah, it's 6.
Yeah.
So 6 to the third. One thing you guys can do is you can think about what your last number would be. If you had 6 times 6, that'd be 36, right? And then times another 6 would end in a 6. So that's one way you kind of think about your different numbers. All right, so this is really x is being cubed plus 6 is being cubed. So when I break it up into my formula, it's going to be x plus 6. You just drop the cubes, square the first number, so x squared. Multiply the two numbers together, 6x. Square the last number, 36. Same, different, plus. So we get that. All right, so if I'm trying to find the zeros, the first one's easy. X plus 6 equals 0. So you get x equals negative 6. This isn't really a quadratic substitution problem. All right, now I can't factor the second one, so what do we do? Can't factor. Doesn't work. What do we do when we can't factor?
Leave it there.
Not a hard question. What do you do when you can't factor, guys?
Quadratic formula.
Quadratic formula, thank you. So x equals negative b plus or minus. Okay, so you get x equals, so negative b, so negative 6 is positive 6. Plus or minus b squared, so if I had negative 6 and I'm squaring it, that's going to be 36. Minus 4ac all over 2a. So you get x equals 6 plus or minus 36 minus 144 all over 2. No. So you get negative 108. So you have 6 plus or minus the square root of negative 108 all over 2. Cut down here. We know we have to break down 108. You can't take the square root of 108. There's going to be an I, right? So you're going to have an I on the outside. Then how does 108 break down? So 108, I know 9 goes into it. 9 goes into it 12 times. So if I had 9 times 12, is there another perfect square in 12? 4, right? So 4 and 3. So if I took the square root of all those different things, you'd have 3 times 2 times the square root of 3. Does it make sense how I did that? When you take the square root of 9, it's 3. When you take the square root of 4, it's 2. Can't take the square root of 3, so it's left. So you end up at 6 root 3. So you're going to have times 6 root 3 all over 2. So your final answer would be 3 plus or minus 3i root 3. You just bring the 2 into both pieces. Okay, so you might get i's for your answers in this section. Okay, the next one says a proton in a magnetic field follows a path on a coordinate grid modeled by the function f of x equals x to the fourth minus 2x squared minus 15. Is that minus? Yeah, minus. So what are the x coordinates of the points on the grid where the proton crosses the x-axis? Okay, so you're trying to find when it crosses the x-axis, in other words, y equals 0. Okay, so you can do the quadratic substitution. You can let w equal x squared if you want. Or remember I said x to the fourth. If you guys are good at those, you don't have to do the w substitution. Remember, you can just factor. So if you're going to factor, you need x squared and x squared. Your last spots need to multiply to be negative 15, and then the outer and inner need to combine to be negative 2. So you're going to need 5 and 3. You need the negative on the 5, a positive on the 3. Okay, set each piece equal to 0 and solve. Because they're not perfect squares, so they don't factor anymore. So you get x squared equals 5, so x equals plus or minus the square root of 5. This one I have x squared equals negative 3. So when I take the square root of both sides, write plus or minus. So you get x equals plus or minus, what do I write? Close, not 3i, I root 3. Right, it's still under a root. And that's it. Those are your two answers. So if you're getting i's, that's okay. I mean, you can always go back and check, and those i's will work. Because remember, if you had like I root 3 to the fourth minus 2 I root 3 squared minus 15 if I was checking. I to the fourth, do you guys remember what I to the fourth was? 1. I squared is negative 1, right? So this would be 1 times square root of 3 to the fourth. So square root of 3 to the fourth is 9 minus 2 times I squared is negative 1. Square root of 3 squared is 3. So you get 9 plus 6 minus 15, that does equal 0. Okay, so see how you can go back and you could check these answers. They would work. So you can still have I answers. All right, let's do section 7.4. It's pretty short. All right, section 7.4 is on the remainder and factor theorems. So it says when working with polynomials, we'll be using synthetic division. So hopefully you guys all remember synthetic division from first semester. Use synthetic division to divide p of x equals 5x cubed minus 13x squared plus 10x minus 8 by x minus 2. So remember we put our coefficients, so 5x cubed, negative 13x squared, 10x minus 8. If we were missing any terms, if I didn't have like an x squared term, I'd put in 0, right? And what do I put in the backwards L? 2, just 2, right? It's always x minus whatever you're going to put in there. Draw the line. You always drop the first term. That's the only mistake that people made on the final. So they forgot to drop the first term. They just wrote like, I don't know. I don't remember what you guys did. All right, and then you had 2 times 5 is 10. Negative 13 plus 10 is negative 3. 2 times negative 3 is negative 6. 10 plus negative 6 is 4. 2 times 4 is 8. Negative 8 plus 8 is 0. Okay, and if you remember, this meant that we had factored our original. So our original was 5x cubed minus 13x squared plus 10x minus 8. We had then factored it into the divisor that we originally had, x minus 2, times the quotient. So this would be 5x squared minus 3x plus 4. That's a 5, negative 3, 4. That's what that represents. Okay, there was no remainder, so that meant that it factored evenly. Okay, so the question is, what is P of 2? So P of 2, if we compute that, we'd have 5 times 2 cubed minus 13 times 2 squared plus 10 times 2 minus 8. Okay, so 2 cubed is 8 times 5 is 40. 2 squared is 4 times 13 is 52. Plus 20 minus 8. So you got a little mental math going on. So you have negative 12. That's these. So negative 12 plus 20 would be 8 minus 8. So you end up with 0. Okay, that's not a coincidence that the remainder was 0 and p of 2 was 0. That will happen every single time. So if your remainder was 7, that means that p of 2 would have been 7. Okay, so it's very kind of strange. Sometimes it's easier to do synthetic division. Can you guys think of big, huge polynomials where it's easier to do synthetic division than plugging in, right? So if I had said, what is p of, I don't know, 25, that might be harder to plug in 25 and cube 25 than actually do the synthetic division. So sometimes it is easier to just use synthetic division. All right, so that's called the remainder theorem. So it says if the polynomial p of x is divided by x minus a, then your remainder ends up being the same as if you had just plugged in a into the polynomial. Okay. It says note if the remainder is 0, like it was in this example, that meant that it factored perfectly. There was no remainder on the end. So that means that we found what's called a 0 of the polynomial. Do you guys remember a 0 is the x-intercept, like an x-intercept? So basically if p of 2 equals 0, that means if you go over to 2, your y value is 0. So it's crossing the x-axis. So that's the factor theorem. So the factor theorem says if it factors evenly, then that has to be not only a factor, but the a value has to be at 0. Okay? All right, it's not really important that you memorize those theorems, just know how to use them. So number 1, it says, let p of x equal 5x cubed plus 32x squared minus 11x plus 75. So find the quotient and remainder when p of x is divided by x plus 7. So I have 5, 32, negative 11, 75. And you're going to divide by x plus 7, so you're going to put negative 7 in the backward cell. Drop the first term. So you have negative 7 times 5 is negative 35. Add straight down, you get negative 3. Negative 7 times negative 3 is 21. Add straight down, you get 10. Negative 7 times 10 is negative 70. Add straight down, you get 5. So your quotient can be found right here. Remember, I always said if it started with x cubed originally, then your quotient is going to start with 1 less. So it's going to be x squared. So your quotient here is going to be 5x squared minus 3x plus 10. And your remainder is that L, so it's 5. Okay, so the remainder theorem says that p of negative 7 has to be 5. Because I had negative 7 in my backwards L, that's the same as if I plugged it in and got that remainder. Or if I plugged it into my polynomial, my remainder is the same thing. So let's try it the other way. So let's say I plug in negative 7. Notice we did the synthetic division without using a calculator at all. It was pretty quick. Didn't take very long. Now if I did this one, negative 7 cubed, I don't know what that is. I'd have to do negative 7 cubed on my calculator. I get negative 343. Then I multiply by 5, still don't know what that is. So I get negative 1715. The next one I have 49 times 32. So you get 1568 plus 77 plus 75. Still don't really want to do it in my head. I could, but when you end up adding all those together, you do get 5. Okay, so see how what I was saying, sometimes synthetic division is a lot easier. Okay, so number 2, this is more like what we're going to be doing in this chapter. So it says use synthetic division to decide which numbers in the list, so -1, -2, 3, and 1, must be zeros. So they must be x-intercepts of the function. Yeah, Melvin?
Okay, so like for any number you like put for p, it's always going to come out as 5.
It's going to come out, no, so like, let's say I had x cubed minus 2x squared plus 7. If I wanted you to find f of 11, you could go and you could plug in 11 and you could get an answer, right? Or you could do synthetic division with 11 and whatever your remainder is, so it's not always going to be 5, whatever your remainder is.
Yeah, so like
that's
for
gonna
that, and for number 1 though, like we got 5, that's the remainder. So like any p that like p of 8.
No, if we try another number, you're not going to get the same remainder.
You're not?
So let's say we try like 8. Is that what you're saying?
No, I'm saying for like b, like if you said p of 8. For b.
But those have to do with each other. So the reason we're trying -7 is because we had x plus 7 there.
Oh, okay.
Okay. All right. Okay, so like I said, we're going to use it to find if we have zeros or not. So this is going to help us factor really large polynomials, because if it's a 0, that means it factors evenly, right? There's no remainder. So we're going to get these huge polynomials, and we're going to use synthetic division to slowly factor them. Okay, so I want to see if these numbers are zeros, so I'm going to do -1, -2, 3, and 1 in my synthetic division. So I'm going to have 1, -2, -5, and 6. You can do one at a time if you want. I'm just setting them all up. Oops. So how about Chris's side of the room, you guys do -1 and 3. And the other side of the room, you guys do -2 and 1. Should have switched them. Make sure you guys get the same remainders I had. Okay, so based on that, which ones are zeros of the polynomial? 3 works. -2 and 1. So it's going to be a 0 the polynomial if it factors evenly. Okay. So what this means is for our polynomial at 3, we go through y equals 0. At -2, we go through 0. And at 1, we go through 0. So you see how this is going to be helpful when we're trying to graph polynomials? Because now if we know the end behavior, we can do a pretty rough sketch of the graph, right? Okay, so number 3, it says find a polynomial of degree 3 with these zeros. So remember, if it's going to be a 0, it's going to factor evenly. So whenever we factored something, it always looked like x minus 2, x minus 5, x plus 7. I mean, that would be like a fully factored form. So in our case, we're not going to use those numbers, though. Our polynomial, you can call it f of x or p of x. We want to have those particular zeros. So if I want -1, I want x plus 1 as a factor. Because I know when I plug in -1, I'm going to get 0 out. Do you guys remember these from chapter 6? All right, so if I want 1, I want x minus 1 as a factor, and if I want 3 as a 0, I want x minus 3 as a factor. And then we just multiply out. I always try to think if there's like an easy 2 to multiply together. Like see how if I choose the last 2 and I multiply them together, you're going to have a trinomial. You'll have 3 terms when you FOIL it out. But see how if you multiply the first 2 together, you have a binomial. Do you guys understand that? Because you'd have x squared minus 1. It's the difference of 2 squares. All right, so when I multiply the first ones out, I get x squared minus 1. And now I multiply it by x minus 3. And I FOIL again. So I get x cubed is my first terms. My outer is negative 3x squared. My inner is negative 1x. My last is plus 3. That's your polynomial. Now notice I said find a polynomial with those zeros. There's actually an infinite number of polynomials with those particular zeros. I mean, first of all, I didn't say that those are the only 0. Well, I guess I did because it's degree 3. So those, you can only have 3 zeros then if it's degree 3. But you could also have any number out front. I mean, I could have put like 7 out front and then multiplied the 7 in at the end. So that's why you could have an infinite number of polynomials.
If it didn't, like if degree 3 like wasn't even written in the problem, would you still do it the exact same way?
I still would because that's the simplest one. But if it didn't say of degree 3, then there could be more zeros, right?
Okay, so by it saying like degree 3 doesn't affect your answer?
When it says degree 3, I know that those are the only zeros, yeah. So
Okay.
you don't have to do any more, yeah.
Like, how would it be different if it was degree 5?
If it said like degree 5 and it said you have those zeros, at least do those 3 zeros, and then you can put 2 more zeros if you want. If it said degree 5 with zeros 1 and negative 1, both with multiplicity 2, do you guys know what you'd do there? So if it said both of these had multiplicity 2. What, Kendall?
Would there be like 2 of them?
Yeah, you'd write it twice. So each one you'd write twice. You'd have x plus 1, x plus 1, x minus 1, x minus 1, and then x minus 3. Make sense? Okay, so the next one says find a polynomial with leading coefficient 3, degree 3, with these zeros. So if you're going to have those zeros, you're going to have x plus 2, x minus 5, and x minus 2. What do you think the leading coefficient of 3 means? Yeah, the number out front has to be 3. Because if I just multiplied the x parts right now, just these 3 terms, you would end up with x to the third out front, right? X times x times x. But we want 3x to the third, because I told you you wanted a leading coefficient of 3. So we put a 3 out front. Okay, now always think about the easiest way to multiply these. Which 2 should I multiply together? The first and the last, right? So when I multiply x plus 2 and x minus 2, you end up with x squared minus 4. That was the difference, 2 squares. Now you have your x minus 5. So when you FOIL, you get x cubed minus 5x squared minus 4x plus 20. And then the last step, bring that 3 in. So your polynomial is 3x cubed minus 15x squared minus 12x plus 20. And that's the only polynomial you could have because it told you the leading coefficient and it said your degree was 3.
20 or 60?
Oh, 60, thank you. Yep, so that's the only one you could have because it said the degree was 3 and you had 3 zeros already. Okay, so there's no more zeros you could have. Does that make sense if you had another 0? That way it would be x to the 4th then. That'd be too much. Okay. Number 5. So the volume of a rectangular prism is given by v of x equals x cubed plus 7x squared plus 2x minus 40. Find the missing measures. So my volume is length times width times height. Weird h. So I don't know what the length and height are. But I know my width is x minus 2. And I know the volume. Any ideas on what we can do? Yeah, Taylor. Synthetic division, so you have your volume. It's basically like you're taking the volume x cubed plus 7x squared plus 2x minus 40. And you didn't know something. You did know the width, and then there's something else we're trying to find. So what we're going to do is we're going to divide this over. Okay, so she's saying use synthetic division and we're going to divide. So we're going to have 1x cubed, 7x squared, 2x minus 40. And we're going to do 2 in the backward cell because we're dividing by x minus 2. Drop the 1. 2 times 1 is 2. Add straight down, you get 9. 2 times 9 is 18. Add straight down, you get 20. 2 times 20 is 40. Add straight down, you get 0. So now that means the 2 question mark boxes, when you multiply them together, you get x squared plus 9x plus 20. So now what? Factor. Oh, Taylor's on top of it. Factor. When you factor, you get x plus 5 times x plus 4. So that means one of the measurements is x plus 5 and the other one is x plus 4. All right, you feel pretty good about that section? Really the big thing is you should know how to use the factor theorem and the remainder theorem. So the remainder theorem says whatever you have in your backwards L, that's the same as if you plugged it in. Your remainder ends up being the same thing, right? And the factor theorem says if you get a remainder of 0, then it factors the polynomial. Okay.
Can you go back to problem number 2? Because I think I missed something.
Oops.